welcome to 47th lecture, and we have been discussing with the network analysis using Laplace transformation. And if you remember, our circuit will be in time domain with R, L, C values provided. Then next step will be to replace this, redraw the circuit in S domain, replacing R by R, that is no replacement for R resistance, replace L by SL and replace any capacitance by 1 by Cs. And if you assume that the initial conditions are relaxed, that is all the capacitor voltages are 0 initially and all the currents through the inductors are 0, then you do not have to write down the differential equation even in time domain. Straight away draw the circuit in S domain and solve for it. So, I will tell you one example. For example, you have a series RLC circuit with R is equal to say 2 ohm, L equal to say 1 Henry and C is equal to say 25 by 9 farad. So, the circuit in time domain is like this: R 2 ohm, then an inductance of value 1 Henry and a capacitor, series RLC circuit. Let us apply this technique whatever we have learned, and this is C is equal to 25 by 9 farad. And our plan is to find out what will be the response of the circuit if a unit step voltage is applied between these two. So, this circuit is in time domain and it is given that all initial condition is relaxed. So, this will be some IT and this will be the voltage across the capacitor at any time t, VCT. So, I 0 minus is equal to 0 because current through the inductor was 0 and voltage across the capacitor at 0 minus was equal to 0. These are the things given to me. Now, I can solve this writing down differential equation classically, that gives you better insight, those things we know, but let us apply Laplace transform method to solve this circuit. So, first step is redraw the circuit. This remains 2 ohm, no change. This inductance will become S into L, value of L is 1 Henry. So, it will become S in S domain, and then this capacitance, it will become 1 by Cs, you recall. So, this will become 9 by 25 S. This is the circuit, and here you have applied a voltage, Laplace transform of that voltage. So, ut Laplace transform of that is 1 by S. So, we want to know what is the current in the circuit and what will be the voltage across the capacitor plate. So, everything you show as a function of S. So, total impedance of the circuit is ZS, all are series. So, 2 plus S plus 9 by 25 into S. Therefore, Is just like DC circuit V by Zs. So, supply voltage, that is Us divided by Zs. This will be the current in the circuit, and this will become 1 over S, Us is 1 over S divided by 2 plus S plus 9 by 25 S. This S you bring, let us first solve for Is. So, Is will be equal to this S you bring below, and it will be 2S plus S square and plus 9 by 25 it will become. Okay. Now, I have to take the Laplace inverse of Is to get the time domain description of the current. This how to do it? So, I must bring this right hand side in some familiar Laplace transform, so that the inverse can be easily identified and written, that is the whole idea. So, general rule is one thing is clear, as you can see, this one can be written as S plus 1 whole square, S square plus 2S at plus 1 and subtract another one. So, that this will become minus 16 by 25. I think you have got this step, at plus 1 subtract minus 1. So, that it becomes a perfect square, because it is so easy to identify that, and this one can be written as any mistake you point out. So, this divided by S plus 1 whole square minus, so minus 4 by 5 whole square, this will be this. So, it can be easily factorized, a plus b into a minus b, everything is real here, no j terms. So, this I will write it as a plus b, if you do it will be s plus 1 plus 9 by 5 into s minus 1 minus plus 1 by 5 plus 1 by 5, it will be like. So, this is a very happy situation, two simple factors are there, these roots are real. So, this can be broken up into parts, these are the steps you have to follow, that is why I am solving this problem. So, this can be written as a by this plus b by this. So, Is is equal to this. Now, if I can find out where a and b are constants to be determined, how to determine these constants? I will follow this rule, there may be several other rules which you can also adopt, but nonetheless you have to break this up into what is known as expand this in partial fractions, partial fraction is the word. So, this thing will be, so Is, so this thing, now you just copy it and go to next page and paste it. So, this is the thing. So, I have assumed this to be this one, is not. How to determine these constants a and b? This is b. Mind you, this will be an identity. So, for any value of s, left hand side and right hand side will be equal. What you do is this, you multiply both sides with this s plus 9 by 5 into s plus 1 by 5. So, that it will become 1 on the left hand side. On the right hand side, you will have s plus 1 by 5 into a, and s plus 1 5 goes for this second term, s plus 9 by 5 into b. This will be the thing, multiply both sides. then this is true, this is an identity, mind you, identity, true for all values of S. So, to put a value of S such that B will be eliminated. So, S equal to minus 9 by 5 if you put on both sides, but on the left hand side there is no S term. So, it remains 1 and this will then become minus 9 by 5 plus 1 by 5 into A, and this term becomes 0, is not. So, this becomes equal to minus 8 by 5 into A, and that is equal to 1, which means that A is equal to minus 5 by 8. We leave it, this is important. Similarly, you put to this, once again come back to this equation and put S equal to minus 1 by 5. It is easily you can see. So, left hand side is 1, right hand side will be 0 into A, it will be, and this will be plus minus 1 by 5 plus 9 by 5 into B, which will be equal to 8 by 5 plus into B is equal to 1. Therefore, B will be equal to plus 5 by 8. So, this is another thing. So, we have almost solved the problem. Therefore, you recall that I s then, remember I s was this. So, this was equal to I s, this itself was I s. So, I s is now written as a like this minus 5 by 8, that is A, divided by S plus 9 by 5, and B is 5 by 8 plus 5 by 8 divided by S plus 1 by 5. So, from this we substitute the values of A and B. Now, we are in a very happy situation. Therefore, take Laplace inverse of both sides, so that it will become I t on the left hand side, and on the right hand side 1 by S plus A, its Laplace inverse is e to the power minus a t. So, it will be minus 5 by 8 is of course this constant into e to the power minus 9 by 5 into t into u t. Mind you, our all Laplace transforms are causal functions, one sided, and this will be plus 5 by 8, this one, into e to the power of minus 1 by 5 into t into u t. So, this will be the answer for the current. So, I have solved for the currents. So, I dealt with only algebraic equations, then express the variable I want to get in terms of S domain, and then you expand it in partial fractions and then try to identify this. So, while taking the inverse I did not apply any formula, just some standard tables are there and I got the result. Now, my next thing was what was VCST. For example, coming here, if I want to solve VCST, one way of doing this, since you have got IT, then remain in time domain and say that VCT, capacitor voltage, will be 1 over C, use this formula 0 to t, because capacitor had no voltage for t less than 0, into IT dt. you have to integrate this and get the capacitance voltage, but this can be easily done. But nonetheless, I will still apply Laplace transform to get VCS. For example, here VCS will be Is into 1 by Cs. Voltage across this is Is into 1 by Cs, its impedance capacitance. That way we will try to see. Is is already is this one. Okay. So, I will say now I am interested to know capacitor voltage. So, I will say capacitor voltage will be VCS will be nothing but Is into 1 over Cs. Now, 1 over Cs, C value is 4 by 25, na? Capacitance value, C value was how much? 25 by 9 C value. So, I will say Is into 1 over 25 by 9. So, it will be 9 by 25 into S, which is equal to 9 by 25 into Is by S. Then you put, already I have calculated Is, that is equal to 9 by 25 will be there. Is was S plus 9 by 5 into S plus 1 by 5, and there is 1 by S another. So, this will be VCS. Here also I have to expand it to partial fraction. So, I will write this quantity as 9 by 25, let it be this side, and here it will be A by S plus B by S plus 9 by 5 plus C by, but C I will not write because you may get confused with this C, say D by S plus 1 by 5. These are the three constants to be determined. Once again, I will determine these constants considering this thing 1 by S into, let me repeat the earlier stage, so that you know what exactly you have to do on pen and paper to get the correct solution. This I have assumed it to be A by S plus B by S plus 9 by 5 plus D by S plus 1 by 5. So, into calculation gulo check korbe. So, now you multiply both the sides by this S into S plus 9 by 5 into S plus 1 by 5. So, that it will become 1 and you will be left with A into S plus 9 by 5 into S plus 1 by 5. This will be the first term. Second will be S into S plus 1 by 5, S plus 9 by 5 goes and into B, correct, and plus D into S plus 1 5 will not be there, these two only will be there. So, S into S plus 9 by 5. Now, here I have to determine three constants. So, first thing is you put S equal to 0, you can put any value of S, no problem. If you put S equal to 0, then this term and this term will become 0 and you will straight away get the value of A. So, A into 9 by 5 into 1 by 5. This will be the thing, other things will become 0, plus 0, plus 0. Therefore, A will be 25 by 9, that is all. Similarly, put A is equal to, so A value is now known, is not. So, put A is equal to, now say A is equal to minus 9 by 5, let us put A is equal to minus 9 by 5. If you put A is equal to minus 9 by 5, so this will be 0 and this term will be 0, and you will be left with 1 is equal to, this is 0 first term, and this term will be plus minus 9 by 5, that is S, into S plus 1 by 5. So, minus 9 by 5 plus 1 by 5, and that is equal to B, and then this term is 0 because A is equal to minus 9 and 5. So, how much it will become? So, this will become minus 9 by 5 into minus 8 by 5, is not, and this is equal to B, this into B. So, minus 9 by 5 and minus 8. Therefore, and this is equal to 1. Therefore, the value of B will be equal to, this will become plus 25 by 9 into 8, 78. Anyway, put 25 by this one is B, that is 25 by 72. This is the value of B. So, put a red mark along this. So, A I have got, B I have got. Finally, I have to calculate D. To calculate D, what you have to do? Put A is equal to minus 1 5. A is equal to minus 1 5, if you put, this term will vanish, first term, this term will vanish, only this term will remain. Therefore, if you put here, I am writing on this page only, okay, this space, let us use it. So, put A is equal to minus 1 by 5 on both the sides in this equation, So, it will be once again 1 is equal to, this will be 0, A is equal to 1 minus 5, this also will be 0, A is equal to minus 1 by 5, and this thing will remain, it will be equal to 0 plus D into minus 1 by 5 S into minus 1 by 5 plus 9 by 5, which is equal to 1 is equal to D into, it will be 8 by 5. So, 8 by 25, and this will be minus, negative sign will there. So, this is minus, therefore, D will be equal to minus 25 by 8. So, I have got the values of A, B and D in this expression VCS. So, VCS was this, and where A, B, D are known. So, this will be, let me write it, okay. A by S, B by S plus 9 by 5 and 9 by 2. So, So, we come here and say therefore, VCS is equal to A by S, 25 by 9 before this one, this factor 9 by 25 was there already, 9 by 25. Then there is a bracket there, A value you just tell 25 by 9 divided by S plus B value. B value was obtained to be 25 by 72 plus. So, plus 25 by 72 and this is S plus 9 by 5, S plus 9 by 5 and finally, the value of D which was obtained to be minus 25 by 8. So, this is minus 25 by 8 and this is S plus 1 by 5. I am now very happy because it is. So, this 9 by 25 you push it inside. So, this will become 1 by S and this will become 25 goes 1 by 8 into 1 by S plus 9 by 5, this 9 by 25 and here it will be minus 9 by 8 into 1 by S plus 1 by 5. Hopefully, it is correct. This is VCS. Therefore, in time domain taking Laplace inverse, it will be equal to Laplace inverse of 1 by S is ut only, is not, plus 1 by 8 into e to the power minus 9 by 5 into t and this is minus 9 by 8 e to the power minus of 1 by 5 into t into ut 9 by 8. Only thing, let us cross check because capacitor voltage cannot change instantaneously. So, Vc 0 should be equal to 0. If that is not happening, then something is wrong. See, Vc 0, if you calculate, this will be ut is 1 plus 1 by 8, t equal to 0, this is 1 and this is minus 9 by 8. So, this is 0. So, this is the expression of the capacitor voltage. Therefore, you see how easy it is now, at least understanding the circuit, redrawing the circuit in S domain and whatever quantity you want to find out, just apply your DC rules. Okay, V is equal to I into R, here it is V s equal to I s and R s, this sort of thing. The third part is this one. The same problem we will now do with another value of capacitance, same circuit. So, I just draw the circuit and try to solve it. So, what I do is this, R is equal to 2 ohm, example 2, R equal to 2 ohm, inductance let it be 1 Henry only and this capacitance value let us change it. Suppose capacitance value is suppose now half farad, C is equal to half farad and let me do it now very quickly. Here the voltage applied is unit step voltage. So, redraw the circuit in S domain which will be R and initial condition relaxed, initial conditions relaxed. That means, the current in the inductor at t equal to 0 minus was 0 and voltage across the capacitor at t equal to 0 minus is 0. These are the time domain description of the circuit. So, I will avoid writing KVL equations because I know initial condition relaxed. So, I will simply write this is 2 ohm, R remains R, inductance remains S into L. So, it will be S only, and this capacitance is 1 over C S. So, that will become 2 by S, is not? And this voltage is your US, Laplace transform of unit step voltage. Do not forget to show the sign, and this current I want to find out. So, in the same way, this current in the circuit will be I s is equal to U s divided by the impedance of the circuit, which is equal to U s is 1 over s divided by 2 plus s plus 2 by s. This will be the thing. Now, let us solve for the current first, and also I would like to know what is the capacitor voltage, capital VCS. These two things I want to know. So, first let us calculate I s. So, I s is this, which is equal to 1 over 2 s plus s square plus 2, and this will then become equal to 1 over, here also you add plus 1 and subtract another 1. So, that it will become equal to s plus 1 whole square plus 1, is not? Then it remains this one, this way you can solve. Now, this is I s. You see, in this case, should I go for partial fraction? You know that I know this looks like this I s itself is in the form of some standard Laplace transform formula. What is that? For example, we know that Laplace transform of sin omega t is equal to omega by s square plus omega square. Mind you, this is u t always there, even if I do not write, I mean that. So, omega by s square plus omega square, and if you Laplace transform of e to the power some a t sin omega t will be omega, wherever s is there, s minus a whole square plus omega square, is not? So, it is already in this form. Only thing this is s plus a. So, taking Laplace inverse straight away, because the moment I know it is in a known form, therefore, I will say, oh, I t will be equal to the Laplace inverse of this quantity is going to be e to the power minus a t, here plus term is there, minus t into sine of, what is the value of omega? 1 means 1 square, and here also 1 is there. So, omega by omega square sine omega t 1 into t into u t. This will be the solution for the current. You remember that I assumed the initial conditions to be relaxed. Let us see whether it satisfies. At t equal to 0, e to the power minus t is 1, no doubt, but sin t will make it 0. Therefore, I 0 is equal to 0 is verified, I 0 plus will be 0, because I 0 minus, because of this initial conditions relaxed, is I 0 minus. Anyway, in the next class we will calculate VCS for this voltage across the capacitor. Thank you.